Okay, so we're going to have a look at this problem of, can you have three variables, all of which are negatively correlated with each other? And this sort of idea might be quite interesting in a range of different practical settings. So, for example, if you're making lots of investments, you might want to make some good investments so that you don't lose money. So you might want to have some of your different investments negatively correlated with each other. So, for example, if the price of fuel goes down, maybe you stand to lose some money. But then if you also invested in airline stocks, this would be negatively correlated with that. Because if fuel prices go down, then airlines are able to make more money. So let's have a look at this problem. Can we find three or more variables all negatively correlated with each other? And just before we start working on this for negative correlation, we'll just have a look at the intuitive picture for positive correlation. So imagine we've got three variables, x, y, and z. We say they're all positively correlated with each other. What does this mean? Well, as x increases, this suggests y should also increase if they're positively correlated, because x and y are correlated with each other. And then y and z are also positively correlated, so as y increases, this implies that z increases. And then z and x, these are also positively correlated, so the fact that z increases, this implies x increases. So all three of them increase together. It's all consistent and makes sense. And similarly, if they decrease, so here using this little arrow just to say x decreases, this implies y decreases. And then this implies that z decreases because y and z are connected. And then z decreases implies x decreases because z and x are connected by this positive correlation. So now, when we look at negative correlation, it gets much more interesting because if we've got the same variables but now there's negative correlation between each pair, let's say that x increases. Well, this implies that y decreases. And then because y and z are negatively correlated, if y decreases, this implies that z should increase. Then z and x are negatively correlated, so if z goes up, x has to go down, so z increases implies that x decreases. And here we've got a problem, because we started off by saying that x increases, and then this seems to suggest that x should decrease. And the same sort of problem applies for y as well, because y decreases, this implies z increases, implies x decreases, which implies that y increases again. And the same for z as well. We get stuck in this sort of ongoing chain of x increases, this implies that x decreases, which implies that x increases, and the same for y and z. So perhaps we can turn this into a proof by contradiction. But at the moment this isn't a rigorous argument, this is just sort of looking at it, trying to understand the problem at an intuitive level. It turns out that our intuition here, this is more based on strong correlation than on weaker correlation. So for example, if you had weaker correlation, the fact that x increases, this might only suggest a very slight decrease in y, and then a really small decrease in y. This might not even have any effect on x or z, or anything significant. So perhaps you avoid this sort of contradiction of x increasing and decreasing. And it turns out that it is possible to have three variables, all of which are negatively correlated. We'll have a look at a very simple, small example here. So if you imagine we've got three variables, English score, maths score, and science score, for three people who've sat different tests, and they've got these scores. So here we can calculate the correlation coefficient using the formula, using a calculator, put it into a computer, however you like to do it. And it turns out that the correlation coefficient between English and maths, you get minus 0.5. So this sort of suggests a weak negative correlation between your English and maths scores. So if you do better on English, you'd expect to do slightly worse on maths on average. Because there's this nice sort of symmetry in the data here, you get the same correlation between maths and science. So you get this minus 0.5, the same between English and science as well. Minus 0.5 is your correlation coefficient there. So we have a look at the data, just between English and maths. If you have a look at a scatter graph here, you can see there is a very slight negative correlation between the two. Of course, we've got far, far too little data to really draw any sort of meaningful conclusion here. But what this does show is that our intuition, based on the sort of stronger correlation, isn't correct, and you can create data sets where you've got weak negative correlation between more than two different pairs of variables.